What is the first moment of the area? Hello everyone. Before we start calculating anything, look at these simple shapes, triangle, rectangles. They look basics, and none of them truly make sense until we understand the hidden concepts. Now, imagine holding a ball in your hand. You naturally place your hand right under its balance point because if you move even slightly left or right, the ball falls. And the balance point is exactly what we call the centroid. And the only way to find the centroid is by understanding the first moment of the area, that's called Q, the hidden engineering behind every centroid formula. The same idea that keeps a ball steady in your hand is the same idea that explains how a massive dam resists thousands of the ton of the water pressure. Q shows us how force flow through real structures. In the next few minutes, I will take this simple shape, the ball, the event dam, and show you one idea they all share. Uh, the key that makes many topic in the mechanic of the material finally. And before we continue, make sure to visit our website. You'll find modern, clear, and practical explanations, the kind of insight that you are hard to find anywhere else, and we fully include in your learning packages. So, stay with me because once understand the first moment of the area, you'll never look the central calculation the same way again.
Our lessons are all connected to make learning easier. Follow our channel and website to the latest updates.
Before we move into the formula, let's look at the real structure. A massive concrete dam holding back millions of cubic meter of water. Where does the water push the most? And where does the total force act? And where is the exact point that the dam feels the pressure? The answer comes from two things. The first moment of the area, that's called Q, and the next one is about the center of the pressure distributions. Without Q and without the centroid, we cannot predict how the dam resists water pressure, and we cannot design its base and thickness and stabilities. This is why Q is not just a formula, it's the bridge between the simple classroom shapes and the real world structures. So instead of jumping straight to the centroid, in this video we built the foundation first. The first moment of the area, also called the static moment of the area. Remember the bending moment. Moment is simply first to distance. Okay. Now we do something very similar, but instead of the first, we multiply area to distance. About for Q area. Okay. And that's the first moment of the area is about the Q is about A times D. It defines two components about the Qx and Qy. The Qx is about the area times vertical distance about y, and about Qy is about the area to the horizontal distance about the x. We mark a point with coordinate x and y, and then we draw distance from that point to the x-axis and y-axis. If we have the several shapes, you can use sigma for each part. Let's calculate the qx and qy for a simple rectangle. The length is about the 3 units, and width is about the 1 units, and the area is about 3 to 1 is about 3. Now this rectangle is located at its lower left corner is about the 2 units away horizontally and 1 units away vertically. So the centroid of the rectangle is about 2 plus 1.5 is about the 3.5, and y is about the 1 plus 0.5 is 1.5. Is about. Now calculate the x is about ai to yi. The first one is about the area of this rectangle, 3 to 1 is area, and 1 plus 0.5 is about distance from x directions, as you see. Okay, equal 4.5. And if you want to calculate qy is about ai to xi is about the area of the rectangle, 3 times 1, and the distance from the y direction is about the 2 plus 1.5, about 3.5, as you see. Okay, equal 10.5. The result is here. One questions about composite sections. You have these shapes and the composite shape sections. Now the shapes is divided into the smaller part about A1, A2, and A3. You can use about the sigma. Each part has its own distance from both axes. You can use sigma about the sigma I from 1 to n about ai to yi. And if you want to calculate the qy is about the I from 1 to n about the ai and to xi. Okay, if the shape has multiple parts like a triangle and semicircle and rectangles, nothing changed. We simply calculate the q for each part separately, and then use the summation about the q total, about sigma q. Sigma qi, it's divided to the qx and qy. Okay, take a breath, because this is the moment everything starts to make sense. You now understand exactly what q is and how we compute it for any shapes. So now you clearly understand q. In the next video, we divide the q by the total area, and it gives us the centroids. If you want to deeper example, solve the problem, extra notes, and full ebooks, visit our website. Everything is explained, and there were with modern, clear teaching method that's hard to find anywhere else. And if you are watching this on YouTube, don't forget to like, subscribe, and follow the next video where we compute the actual centroid. And don't forget that the destination matter, but how you walk the patch defines you. Until the next video, dear ones.
Our lessons are all connected to make learning easier. Follow our channel and website to the latest updates.